So we're going to start a new chapter, chapter 3, and we're going to be talking a lot about quadratics. Okay, what do you guys remember about quadratics, if anything?
For something.
For something. What does that mean?
I don't know, quad.
Oh, okay. Quad means 4. All right, yes.
Sorry.
What do you guys know what a quadratic looks like if you had to graph it? No?
Factory reset over break.
What's this called? What's the technical name? What? Parabola. Okay, we're going to talk a lot about parabolas in this chapter. We'll talk about the different ways that quadratics can be written because there's 2 different ways that they could have an equation. There's something called vertex form, and then there's like the standard form, or maybe the ones that we're more used to seeing. And then we'll talk about how to look for things that we would need in order to graph the parabola. So how do we find the vertex and our intercepts, our axis of symmetry, like all of those things that help us put the graph onto the coordinate plane. So we're going to talk a little bit about vertex form first. Vertex form is a little, I would say, different than what we're maybe used to seeing with quadratics. Most of the time with quadratics, you see this, where a, b, and c are numbers, but you have like an x squared, an x, and then plus or minus a number at the end there. Vertex form looks a little bit different because it has parentheses involved. And so we're talking about almost looking at the original parent graph, like just y equals x squared, and we're adding on transformations to it that cause the graph to move left, right, up, down, those different kinds of movements that we talked about towards the end of first semester. So what we're going to go over today is how to kind of read this vertex form and then also being able to use that information to help us graph it. So I'm not going to get into graphing quite yet, but I'm just going to kind of talk through if you had an equation written in this form right here, like what's the important information that we need to be able to pull from that in order to make the graph. So the first thing would be you need to be able to identify what your vertex is, because that's like your starting point. That's in the middle of the graph. That's going to really determine like a lot about what happens. Like, does it open up? Does it open down? Is it a maximum, a minimum? Like all of those things. And so your vertex comes from inside of that form up there. Do you guys see where the H and the K are, those letters? That's going to be used for your vertex. So your vertex is just going to be a coordinate, H, comma, K. The only thing you need to remember is with the H value, so the number inside the parentheses, you have to pull the opposite sign because it always starts x minus whatever that number is. So if this were to become like x plus 3, that's because they put in a negative 3 in there. So you'd have to remember to pull the opposite sign of what you see inside of those parentheses. That does not work the same way with the K. The K is whatever number it is, whether it's positive or negative, you just pull that one. You don't change the sign of the K. You only change the sign of the H. There's something called a line of symmetry, and this would be just a line that cuts through the vertex. It makes that symmetrical shape of the parabola. So everything on the left side of the line is going to be the same as everything on the right side of the line. Sometimes we use the line of symmetry to help us graph points. If we know where one of them is on one side of the graph, we can just reflect it over that line of symmetry. To graph the line of symmetry, you just need to know whatever your H is. Whatever your H value is going to be a line that we graph on our x-axis. So it's going to be x equals whatever that number H would be from our equation up above. We're going to graph that on the coordinate plane. Usually when we graph it, we use a dotted line to represent that point because it's just kind of like the mirror that's happening and it splits that parabola in half. To determine if a graph opens up or opens down, or if it has a minimum or a maximum. So something that opens up would look like this. It'd be, I always call them happy parabolas because they look like they're smiley faces. Okay, so a parabola that opens up would have a minimum value. The minimum value would be down here, and that would be its vertex. That'd be the lowest point that you find on the graph. Then if you have an opens down, that would be like, I call them a sad parabola because it looks like a frowny face. But again, that would have a maximum point because the vertex would be at the very, very top of your graph. Now, to determine if the graph would be opening up or open down, you have to look at your A value. The A value would be the number that's way at the beginning. If your A is positive, it's going to open up. So it's going to have a minimum. If your A is negative, it's going to open down. And it's going to have a maximum. To find your x-intercepts, that's when you set your y equal to 0 and you solve for your x. When you solve for your y-intercepts, that would be when you set your x equal to 0. On a parabola, the x-intercepts, there could be one x-intercept, there could be two, there could be 0. It just kind of depends on what kind of graph we have and if we're having to deal with imaginary numbers at all. So when I talk about x-intercepts, I'm just going to draw you guys a picture over here. If I had a coordinate plane, I'm going to draw 3 different cases here. For it to have one x-intercept, that means that your vertex is on the x-axis. So it'd be a parabola that looks like that, where it hits the x-axis one time at the vertex. If it has 2 x-intercepts, it would be a parabola that crosses that x-axis twice. Most of the time, I would say that's the case that you're going to be dealing with, because most of the time we're going to have 2 solutions to our quadratic. But we have talked about the imaginary number before, and so that would be a parabola that looks like this. It doesn't cross the x-axis at all. If that shows up on your graph, that just means there's no real solutions. There would be those imaginary numbers out there somewhere. All right, so what we're going to do now is actually look at an example, and we're going to pull all this information. We're going to find our vertex. We're going to find the line of symmetry. We're going to decide, does it open up or does it open down? And then actually find the intercepts to help us just graph it. Okay, so down below you can kind of see it's a little different because they're actually putting some numbers in now. It says f of x equals negative parentheses x minus 1 squared plus 4. Don't forget about that negative sitting in the front because that is important. And just a quick reminder, f of x is the same thing as y. So I'm just going to put a little y above f of x because that's really what that means. It's just that's function notation. And we use that in case we're dealing with a lot of equations at one time. It's easier to say f of x, g of x, h of x instead of saying y equals y equals y equals a bunch of times and getting confused. Okay, the first thing we want to do is find our vertex. Remember that comes from your HK. With the h though, you have to think opposite sign. So what number's in the h spot right now? 1. You have to pull out a positive 1. I know it says negative 1, but you guys need to pull out positive 1. And then what's the k value? 4. So 1, 4 is our vertex. I'm going to go ahead and just draw that point over here on my coordinate plane. So I'm going to go over 1, up 4, draw that first point. There's my vertex. What I also like to do then, just so I know which point is my vertex, because this is going to be where the graph really forms itself. This is going to be where it opens. I like to put in my line of symmetry right away. So remember, your line of symmetry is whatever that x value of the coordinate would be. So we said the x was 1, so my line of symmetry is going to be the line x equals 1. And I'm just going to draw that in as a dotted line. So it's going to go straight up and down through that vertex point. Again, I like to do that right away because sometimes when kids put points on the graph, they get lost on what's the vertex and they start to connect the points incorrectly to get the wrong shape of the graph. So I always put the vertex on first and draw that line so that I can see clearly where's like the center of the graph at. All right, let's figure out if this graph is going to open up or down. Is it going to be happy or sad? Where do we look for that? The A. Now, where's the A at here? In the very front. What number's in the very front? Negative 1, right? So my A, I'm just going to write here, A is negative 1. So if it's negative, is it going to be happy or sad? Sad. So it's going to open down. So that just gives me an idea, like when I start to get other points, they should be down here on the graph. They should not be up above, because then you'd have a parabola that opens up. That doesn't make sense if it's negative. If it's negative, it's got to be opening down. So this just lets me know, like, my y-intercept and my x-intercepts need to be in this area somewhere so that I get my frowny face parabola, okay? Now let's do the hard work, which is finding the intercepts. X-intercept is when you set y equal to 0. So back up in our original equation, remember I said f of x is where your y is. So you're going to put a 0 in for that. So it's going to say 0 equals this negative x minus 1 parentheses squared plus 4. And we want to solve for x here. Because I have this quantity that's squared in parentheses, my advice would be to get that term by itself. Because if I can get the x plus 1 or x minus 1 by itself here, and it's got that squared, I move everything else over to the other side, I can use my square root property, where I can square root my sides in order to get to my solutions here. So I want to move that 4 over first. Since it's plus 4, what would I do to move it over? Minus. So now it would say negative 4 equals negative, and then still x minus 1 squared. Let's get rid of that negative sign. How would I do that? Divide by negative 1 on both sides. All that's going to do is change the sign. So this negative 4 becomes positive 4, and then it equals x minus 1 squared. So hopefully you can see now, I got that quantity in parentheses by itself. It's all squared. So what I want to do is square root both sides. Okay, so that's my next step here. What's the square root of 4?
2.
Technically, what should be in front of it?
Plus or minus.
Plus or minus 2. So the square root of 4 is positive or negative 2. And then over on the right side, what happens when we square root all of that stuff? It's just x minus 1. So I'm looking for 2 answers here. Because I had that squared, there could potentially be 2 x-intercepts out there. I need to now add the 1 over to that plus or minus 2. That means you're going to do 2 plus 1 and negative 2 plus 1. What do you get for answers? 3 and negative 1, because it'd be negative 2 plus 1, right? So it'd be a negative 1. Now think about these as coordinates. This is 3, 0, and this is negative 1, 0. Because if it's the x-intercepts, the y's are always going to be 0. Because that's what we set in. We set in 0 for y, and we got these 2 answers. So now I'm going to graph these 2 points over here. So I've got one at 3, 0, and one at negative 1, 0. If you look at those in relation to that dotted line, they should be symmetric from each other. They're both 2 spaces away from that dotted line there, so it's looking good so far. All right, and then the last thing we need to do is find our y-intercept. So y-intercept would be when you set your x equal to 0. So back up in that original equation, we're just going to put a 0 in for x, and we're going to solve for y. So instead of saying f of x equals, I'm going to say y equals, and it would be negative. Instead of x, I'm going to put 0 minus 1 squared plus 4. Watch your signs on this one, especially that negative. If you're using a calculator to help you do this, which you can, just make sure you type it in correctly with the negative there. Okay, but you can also do this mentally. What's 0 minus 1? Negative 1. What's negative 1 squared? 1, but there's a negative in front, so now it's back to negative 1, and then plus 4? 3. How would I write that as a coordinate? 0, 3. There's only one y-intercept. So I'm going to go ahead and graph that point, 0, 3, which is right there. Now, if you wanted to, because maybe you're like me and you like things to be symmetric and you like everything to match on both sides, I could reflect that point over here because it's just 1 space away from the blue dotted line. So I could go 1 over from the blue dotted line to just get another point so that my parabola looks symmetrical on both sides. You don't have to do that. You don't have to have that extra point if it doesn't bother you to have like 3 on the one side and 2 on the other side. But just know that that is what some people will do. They'll just put that point over there because they know it should reflect over. Then you guys should connect. Okay, when you guys connect those dots, it needs to be like a fluid movement. No dot to dot lines here. Okay, we're not doing stick straight segments in between our points. It should kind of like flow as like a curved unit to make that U shape. Questions on that one? Okay, let's turn our page over. Let's do another one. I'm going to have you guys kind of take the lead here, though.
No.
Yeah.
Take charge.
Take charge. We're going to start by finding our vertex. What say you guys? Very good. I'm going to go ahead and graph that point. So -3, down 4. Where would be that line of symmetry? And I'm going to abbreviate line of symmetry here. It'd be where? -3. How would I write that? Like as an equation here? Is it x equals? Okay, and then again, that's just a dotted line, remember? So I'm just going to go ahead and draw that in. Again, that just reminds me that's the center of my graph. That's going to be symmetrical on either side. Okay, let's talk about how it opens. It opens up.
Yeah, 'cause A is positive.
A is positive this time. A is 2, which means it's going to open up. Okay, it's positive, so it's going to be a happy parabola. So it's going to be like a smiley face on here. So at least now we kind of know where our x-intercept should be, where the y-intercept might start to kind of play in here. We know that it should be going up in our coordinate plane, not going down. So if you start to get upside down parabola, that should tell you that I probably am graphing something wrong or I'm solving for something incorrectly. Okay, now let's talk about how to find our x and y-intercepts. Let's start with x-intercept first. What do we do to solve for the x-intercept? What'd you say? Put 0 in for y. So I'm going to say 0 equals 2 times x plus 3 squared minus 4. And we're going to want to do what we did on the last problem. We're going to want to isolate that quantity that's squared so we can use our square root property. So what would you guys like to do? Well, I wouldn't distribute. Add the 4. I mean, you could distribute if you really wanted to,
Nah, I'm chill off that.
but I think it's going to make it way more complicated.
I'm chill.
Now what?
The other two.
Square root. Okay. Approximately, what's the square root of 2? 1 point what? 1.4. Now we're going to need to write it like that. Okay, because I need physical points that I can graph here. So technically 2 can't be square rooted nicely. So if I was just looking for the answers, I would maybe just leave it as plus or minus the square root of 2. But because I actually need to put this on a graph somewhere, I don't necessarily know where plus or minus something square root of 2 and then I have to add or subtract another number from that might be. So I maybe need to actually work with the decimal here. So that's why I'm saying let's go ahead and square root that. Let's round it. This is a rough approximation of where we think these points are going to be. What would you guys do next? Minus the 3. So you're going to do positive 1.4 minus 3 and negative 1.4 minus 3. What do you get? Negative 1.6 and then you were giving those to me as coordinates, right? Good. And now we're going to graph those points. Again, because they are decimals, we are roughly guessing where we think these are going to be. So do your best. They don't have to be perfect. Okay, we still need to find our y-intercept though. How do we do that? Okay, so I'm going to do that over here just because I'm running out of room. So I'm going to write down what you guys said, which was to say x equals 0. So back up here to my original equation, I have 2 times 0 plus 3 squared minus 4. What is that going to give me? 14? That's what I got. How would you write that as a coordinate? 0, 14. Now, is that going to fit on my graph? No, it's not. But you guys at least have an idea of where it's going to be. It's going to be way up here somewhere. Like mine's going to go off my graph there. But you at least have an idea of where the y-intercept is. And we actually found the coordinate, which is maybe the more important piece of information. So I'm just going to go ahead and graph that. Now, granted, if you did not include 14, your graph may not go up as high as mine does. And that's okay. If you can't reasonably fit the points, they maybe don't need to always all be there. The vertex and like those x-intercept points should be enough for you to be able to graph your parabola. The y-intercept is just an extra piece that might be helpful for us. All right, do we have any questions on how to graph using vertex form? Okay, remind me what time did we get out of here today? I can't read that. 11:08. Okay.
Might as well chill for the rest of the day.
I think we're going to pause here, but I am going to give you guys the homework.